So when it came to the acidic and basic environments for redox reactions, we didn't have to worry about the oxygen and the hydrogen because we could just add waters to balance the oxygen and add hydrogen ions to balance the hydrogen. But what happens if we are not in the acidic and basic environments and we can't retreat to water and hydrogen ions? Then we might just have to balance the old school way. So you can think about these redox reactions in neutral solutions as the Goldilocks zone. Remember that in neutral solutions, the pH is roughly 7, so it's not too acidic and not too basic. Now, unlike acidic or basic solutions, there's no excess H plus or OH ions. Neutral solutions have equal amounts of both. And while that may be ideal for safety in terms of chemical conditions, when it comes to balancing, it really just makes the process a lot more difficult. So you'll still use the same oxidation number method, but now you need to be extra careful about the H plus and OH minus. In fact, we don't add those anymore. So when it comes to neutral solutions, steps 1 to 4 are going to be identical to balancing in acidic or basic conditions. But once we've balanced the electrons and we've balanced the atoms, you can't simply add H plus and OH minus anymore. Now we just have to do the old school balancing methods, and some people say just try numbers out until you get it right. And that's where the patience comes in. So bear with me, we're on for a bumpy ride. So the first thing we're going to do is we're going to assign oxidation numbers to each element in this reaction. Next, we're going to find out which substance was oxidized and which one was reduced based on the change in oxidation number per atom, so not the totals. Now, to ensure that the law of conservation of charge is obeyed, we've got to make sure that the electron loss is equal to the electron gain. And so to do that, we're going to get the lowest common multiple between the oxidation and the reduction sections of this reaction here. So between 6 and 4, that is going to be 24. That's the lowest common multiple. And so that means that we're going to have to multiply this by 4 and then this by 6. And those multipliers, the 4 and the 6, are going to go as coefficients in order to start the balancing process. Now we're going to balance all the non-oxygen and hydrogen atoms the same way we would balance them in a normal chemical reaction. So if I look here, if I start with the bromines, I got 4 and 4 here, so those are okay. And then for carbon, I have 12 on this side and 6. So I'm going to scratch that out and put 12. And then that would make the reaction so far this. And I'll write it in blue below. And then unfortunately at this point, we can't retreat to waters and H pluses and OHs to balance the hydrogens and oxygens. So we're just going to have to play with numbers here and keep working at it until it works out. And so finally, our balanced reaction is 2BrO3 minus plus C2H6 yields to 2 moles of carbon dioxide plus 2 bromide ions plus 3 waters. Whew, that was tough.